Am I audible to you all?
Yes.
Yeah, thank you, Bala. And screen is visible to you? My screen is visible to you?
Yes, yes, sir.
Okay, thank you. So yesterday we have discussed about creating variables and assigning the values and some of the basic data types like int, float, string, and boolean. And we will discuss today some more data types also. And then Python is a dynamic typed language. That means you need not to declare any variable explicitly. So whenever you assign a number a is equal to 10, automatically a becomes an integer type. And suppose if you assign a string to a variable, this a variable is a string data type. Suppose if you assign a decimal number like 2.5 with a floating number, so this becomes n is a float type data type. Okay, so like this. So depends on the value you assign to a variable, Python will automatically changes that data type. Okay, and the comments, how to define comments here. Single line comments can be given in hash symbol, and multi lines can be given with a triple quotes, with a single or double quotes. And in strings here, we can take here string within a single quote or a double quote. I told you this one also in the last class. And also there are some built-in constants. Those are nothing but here true, false, none kind of things here. And how to define a variable. Variable names always must start with a letter, and it can have an underscore. Only allowable character is underscore. So we can define variable names like this, and this is not valid because it starts with a digit number. So always a variable name must start with a letter, and variable names cannot start with a number, and variable names can only contain alphanumeric characters, and only underscore is allowed. So capital A to capital Z, and capital small a to small z, and 0 to 9, these are the allowable characters to define a variable. Okay, and variable names are case sensitive. That means name is different from capital letters name. This is a different variable and this is a different name. This is different variable name. Okay, and variable names cannot be any of Python keywords like true, false, none, or some print or int. So that kind of keywords you cannot give as a variable names. Okay, now coming to today's topics, that is some more data types we will discuss today. Data types. So basically, what is the purpose of a data type? To allocate some memory in the computer to store the value. That is the main purpose of a data type. Okay, and Python provides us 14 data types, totally 14 types of data, and they are classified into 6 categories. Okay, what are those? Number one, these are the fundamental data types. Those are int, and second one is float, and third one is boolean type, and fourth one is complex type. These are the basic or fundamental data types. This is the first category. Okay, and second category is, so we can take this as a Roman letter, and this is second category. These are sequence category, sequence data types. Those are str, that is strings data types. And second one is here bytes. And third one is byte stream, sorry, byte array. And fourth one is range. So these are the sequence type of data. That means a series of letters or series of bytes or series of some numbers can be stored in a variable. Those are called sequence data types. Suppose here in our Python editor, suppose if we take
okay, I found this on the web for
sorry. Where is this Python PyCharm? Okay, this one, right? Okay, I'll open it again. Ideally, I'm opening just testing for some of the examples here. So this is ideally Python version 3.12. Here, if you store a string or name, some name is equal to Srinivas. Okay, I typed like this Srinivas. So this is a string, right? So this is a sequence of characters. This is a sequence of characters. That means here this name contains these many characters. So we can also access each character by using indexes like name of variable name of 0. 0 is nothing but first index value, that is s. So in this first index, that is 0th index, s is the character. Like that there are totally these many number of around 7 or 8 8 characters are stored. Sequence of characters, that is the string data types. String data type. Like that, we have bytes, byte array, and a range. So these are called sequence data types. And then third one is list category, list type of data, list types. These are called, we can take them as collections data type, collections data type.
For sequence data type, can we check the type dot name? I mean, like what type of earlier yesterday you
We can always check it. Yeah, we can always, all data types can be checked using this, type of, for example, if you want to print what type of data, I wanted to print the name as well as type of that particular data, that variable. So we can give like this. So Srinivas is a string kind of data. This. Okay, like as usual, suppose A is equal to 10. If you want to print A and also type of that A variable, we can also print it. You can also check that value.
No, I'm just checking that there are in the sequence data types we have byte and byte array, right? Can we check the
Yes,
class
yes.
name, the name byte and byte array?
Yeah, we can check them also. We will discuss it in the coming
Okay,
sessions. So we are
okay.
discussing one by one. Okay. And the collection data types are here. These are uh, list type, and second one is tuple. These are the collection data types. And again, fourth type of data is also available. That is also collection. Uh, these are set and frozen set. Can I increase this or decrease this style configurator? Then like 10, save and close. Okay. Enable set global font size. Okay, fine. So frozen set it is. Like that, we have fifth type of data, that is also here collection only. And these are number one, dictionary type. You can also call this as dictionary. And sixth type is here none type, none data type. This is only one, that is none. These are totally 14 data types available in Python. Those are classified into 6 categories, that is fundamental, sequence, collections, and again in collections, again here there are listed tuple, and here in these collections set and frozen set, and in these collections here dictionary and none. So these are the totally here 4, 4, 8 plus 4, 12, that 13, 14 totally. That I will tell you. Again, collections are again there are mutable and immutable data types available. Mutable and immutable. That means change. We can change the values, and some data types we won't allow to change the values. Those are the differences between these lists and sets that we will discuss in the coming sessions. Okay. Now coming to we have already discussed about these integer types, right? So integer types are nothing but here suppose a is equal to 10 now, so now it is a integer type. So basically here in Python in Python along with integer type we can also store some different number systems, like you may be hearing about uh, like decimal number system, binary number system, hexadecimal, octal number systems. Did you hear about them? Decimal. Okay, so yeah, these are the different number systems. So that also supports Python. Okay, so basically there are 4 types of number systems. That is number 1, decimal number system, and second one is binary number system. Third one is octal number system, and fourth one is hexadecimal number system. Okay, these are the 4 kinds of number systems, and it also Python supports these all 4 types of number systems. So nothing but here these decimal numbers are nothing but it is starting from 0 to 10. 0 to, like here this number system contains number 1, this we will have this decimal number system. In this decimal number system here this is the default number system in any programming language. Okay, and this number system this system contains digits only, that is digits, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally here how many digits here? 10 digits. Okay. So totally here 10 digits. So this base is 10. Remember this one, base is 10. So these 10 literals are numbers are called decimal number system values. Okay. And second kind of number system is binary number system. Here this binary number system is understood by only operating system and processor. Computers can understand only this binary number system. So this contains here binary number system is understood by OS or operating system and the processor. Okay, and this system contains digits. What are the digits here? It contains only 0 and 1. Only total 2 digits. Total 2 digits only. And this base is 2. Okay. That's why it is called binary. Binary means 2. So in Python, to store any binary values, we can store like this variable name. Variable name is equal to 0b. This is a binary data. Or we can also store like variable name is equal to, we can also store like 0 capital B. This is a binary data. In Python, we can store this binary data with the help of a number followed by B, a small b or a capital B. So if you store binary data in Python, Python execution environment automatically converts that into decimal types, like integer only. See, for example, if I store this, for example here, some a is equal to 0b1101. This is what type of data it is? Binary number, right? So if you want to check what type of data stored here, so print of that a, and also type also, if you want to print here type of a. See here, this is integer type only. So all these number systems are belongs to integer type only. You need to remember this one. Like here, you can also store some b is equal to 0 capital B 111, only once here. I am storing this number. So print of that b value along with what type of data stored in this b. It is also integer type. Understood this? See how we get this 15 here. Converted that total numbers into decimal numbers. Internally, it stores that value in a decimal digits only. So that's why it is treated as an integer type. And basically here, to convert any number to a binary number. For example, if I want to convert, suppose what is the value here? 15, right? 15 is 1111, right? So suppose if I store c is equal to 15. Suppose I want to convert, like print of here bin. Using bin function, we can convert that into here decimal to binary number. We have converted that actual decimal number is 15. We have converted that into binary number using bin function. So this is all about binary number system. And third one is here octal number system. So octal means here total 8 digits. Actually, these octal numbers, this octal number system is understood by microprocessors. Okay, like 8086, 8086 and 8086. These are the microprocess numbers, microprocessors. So these number system is understood by only these microprocessors, and this system contains how many digits here? I told you 8. So total digits here, digits are starting from 0, 1, 2, 3, 4, 5, 6, 7. That's it. So total digits are 8. Total 8 digits. Okay. And base is, what is the base here? 8. Okay. So base is 8 here. This is called octal number system. And to store this octal data in Python, we use here a letter 0, O, or, so here we can take this here. This examples here, variable name, and variable name is equal to 0, O, is octal data, or variable name is equal to 0 capital O. See the difference here. This is 0 and this is O here. This is octal data. Even we store this octal data in Python, this execution environment automatically converts that into decimal number system. Okay. So as I told you here, one example, this is the, here what is this here? This is the example for binary. Likewise here, suppose here I have taken a variable, a is equal to 0, 33 or 44. Now if you print this value here, what type of data it is now? What type of data it is? Okay, we know that it is an octal number, but Python automatically converts into integer, right? So that is integer type only. 36 is the equivalent number for this octal number. We have stored this 0, O is the general standard to store octal numbers. That may be a capital O or small O.
Python converts any data into integer.
Integers only. Any number system, it may be a decimal number, by default decimal numbers only. Binary number system or octal number system or hexadecimal number system automatically converts into integer only. Okay. If we want to see the equivalent number, for this, here we use OCT, oct. Like here, print of OCT of A. So 0, 44 is the equivalent number for 36. That means suppose here we have taken B is equal to 36, and if you want to print it OCT of B, so this is like 0, 44. Like that here, A is equal to 0, O, capital O, 1, 2, 3. I have stored what type of data it is? Octal number, right? Octal number. Suppose here, if you want to print the value along with a type of data, it is integer type only here. Internally, Python store this number as an integer type. Now, if you want to convert that integer, that normal decimal into octal number, so we can use this print of OCT of B, we can take 0, 1, 2, 0, 0, 1, 2. That
Brain
is
cell.
how we can,
We can see
yeah,
bin
please.
also.
Bin
Binary.
also we can see. We can see, so for example, if you want to convert this 83 into binary digits, so bin of we can also convert it. This is the equivalent number in binary number system
Okay.
for
In real
83.
time, are we using anywhere this oct and binary values and just for information?
Actually, in our general, in our domain, like what we have chosen full stack web development, right? Python web development. In this basics, I am telling only. Okay, this is the foundation for all other, we won't use these kind of number systems in any of our real-time examples or real-time scenarios. Only for your basics understanding purpose, I am telling you. Python supports all these kinds of number systems. Okay, tell me.
Can you see capitals also? So you can see two types of variation.
No, no. While declaring and initializing values, we can give capital O or small o for octal numbers. 0 O or 0 capital O. But always it is printing only small letters. Yeah. When we are converting that decimal number to octal or binary, it is always taking this small o and small b's only. Okay. And the last number system, that is hexadecimal number system. This hexadecimal number system is used in development of operating systems, and this contains digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After that, A is 10 and B is 11 and C is 12 and D is 13 and E is 14 and F 50. So these are the total 16 digits. So that is base is, what is the base now here? Base is 16. So these hexadecimal number systems are used in development of operating systems. So in Python, to store this hexadecimal data, we use here 0x. So variable name is equal to 0x, or we can use variable name is equal to 0 capital X. Both are same. These are called hexadecimal data. So even we store this hexadecimal data in Python, Python automatically converts this into decimal number system type only. Okay. So examples you can take this like, for example, if you want to store A is equal to 0x of numbers like 172. So we can print that value by using x of A. And here we can also convert that So what type of data it is now here? We print it here, print of A, type of A. So this is 370 is the equivalent number for this 0x172. That is of integer type only. And I told you about complex data types. So that also we won't use it, but I am just telling you. Now here integer number systems are in Python. Every number system, it may be a decimal, binary, hexadecimal or octal numbers, can be treated as integer numbers only. But we can convert the general decimal numbers to the corresponding octal or hexadecimal by using these functions hex or OCT or bin, like this here. Here oct or bin or hex. Okay, and as you know already, this float type is containing a number followed by a point. See, for example, if we want to store a number, for example here, suppose okay, always it is taking the pulling upward. Okay, it is showing downwards. That's why I don't use this basically. Okay, now we'll use this one. See, the general notation for complex numbers. See, complex numbers, I'll tell you about them in this notepad only. So here, complex numbers. Just I'll tell you about this complex numbers. If you like, the general notation for these numbers are generally it stores the numbers as some x plus yj or x minus yj. So this is the complex numbers notation. Okay, and here x is a here x is called real part number, and here y is called imaginary part. Okay. And j is nothing but a square root or minus 1, square root of j or square root of here, and j here, and j represents sqrt of minus 1 or sqrt of j, that is equal to minus 1. So internally these real numbers are converted into two parts, that is real part and imaginary parts. These are called complex numbers, and these are treated as float type data. You need to remember this. See, for example, I'll tell you one example here by showing this editor. Instead of going because ఇక్కడ మనకి ఈ ఎడిటర్ లో మనకి కింద కనిపిస్తుంది కదా, నాకు అది ఇష్టం లేదు. ఇట్లా ఇక్కడ మీకు కనిపిస్తుంది, లాస్ట్ ఉంది ఇక్కడ అసలు పైకి వెళ్ళట్లేదు ఇక్కడ. సో అందు గురించి నేను ఇక్కడ షిఫ్ట్ అవుతున్నాను, ఇందులోకి పడుతున్నాము. సేమ్ కమాండ్స్ ఇక్కడ. ఫర్ ఎగ్జాంపుల్ ఇక్కడ మీరు a is equal to 2j అని అనుకోండి, a is equal to 2j అని అనుకోండి. సో ఇక్కడ ఏంటి మనకి ఇక్కడ ప్రింట్ చేశారంటే ప్రింట్ ఆఫ్ a వాల్యూ, అండ్ హియర్ వీఆర్ ప్రింటింగ్ టైప్. వాట్ టైప్ ఆఫ్ డేటా ఇట్ is? Complex type, right? Like that b is equal to some minus 5j. Here we can take that value, and also type of that value is b is complex only. Internally it stores like this. Suppose if you have taken a is equal to 10 plus, or okay, 10 plus 5j, okay. Now you print the value of this a, and along with type also it prints the complex type, right? But if you want to take only real part of this number, so we can take this using a dot real. These are called attributes. So here if you print that, here 10, here a contains a is equal to 10 plus 5j. So if you want to take only real part of this complex number, we can take that out from this complex number, that is a dot real. So I told you this is converting automatically into float type. So that's why it is displaying here 10.0. Like that, here we can also extract imaginary part from this number by using imag. So here if you print that a dot imag, here see 5j is right, 10 plus 5j, right? So 5.0 is the imaginary part of the a number. See, generally in our web development or in our full stack development programming, we don't use all these types, just for the sake of basics I am telling you. But again, somewhere if you come across this kind of but interviews they will ask these basics. You need to remember this. In interviews they will ask this kind of fundamentals. So these are called imaginary part and real part of a complex number. Okay, suppose if you store this b
So in the
is equal
second
to,
example, hello, how do we get that minus 0, minus 5 where we are printing the value of b?
Yeah. Why? Because here it has stored here minus negative number. So internally it is storing like this. This is the internal storage value of this b value, minus 5bj. Actually we have stored b is equal to minus 5j. But if you print the exact number of that b value inside the Python, it stores like this, minus 0, minus 5j. But general whole numbers like positive numbers can be stored exactly the same way. 2j, a is equal to 2j means 2j only. But only for negative numbers it is storing like this.
So if you give only imaginary part, Python will background do the real part.
Okay.
Minus.
Yes.
By default, it will create a
Real part. So now suppose if you give here 3.5 plus 5.6j, if you give like this, so what type of number it is? It's a complex type only. And if you extract the real part of this number, print of this b dot real, it prints this 3.5, as well as if you print that print of b dot imaginary part. So this is the 3.5 and 5.6. These are the values extracting from this complex number.
How about the j value?
No, j is nothing but is the complex number indication. It doesn't have any value here.
are the regularly used data types?
See, regularly we use these basic data types. Those are initially I told you this integer, float, boolean, and string. And see, we won't use bytes and byte arrays also. We will use string. So remember this integer, float, boolean, str, range, list, tuple, set, frozen set. Frozen set also frequently we won't use. Only we will use in these collections. We will use mostly dictionaries and lists only. These two sets and tuples minor. That's not majorly we use. We use only this kind of collection data types, lists and dictionaries majorly.
Okay.
And frequently we use this integer, already that integer,
Right, right.
float, str. Yeah.
Sir, my question, why three types of collections? Sir? Why there is a three different types of collections? Sir? Why they was categorized into three types?
Yeah, because internally here, these lists and tuples have different characteristics. I will tell you in the upcoming classes. Okay, and sets and frozen sets have its own set of characteristics. And dictionary is different data type. This is a different data type, but for in all the data science applications, we use these dictionaries and lists mostly. Okay. Now coming to the other important uh, data type, that is strings. So we'll take it as just one here. STR. So in this one, we will learn about the purpose of STR and definition of STR, types of STRs, and notation used for storing STR data type, and then memory management of STR data, string kind of data, how the memory is allocated, operations on STR data, string data type. So these operations, generally we use two kinds of operations. Those are number one, indexing. We will use indexing. This is important one, and also this one is also important. Slicing. These two are operations we will discuss. Examples. So str is we already know that str is a string kind of data, right? So it may contain like see when you go to this Python notebook here. Suppose if I use here some s is equal to, you can take any name, but that should be a valid variable name. Okay. Why it is okay? Fine. It's visible to you? Fine. For example, now I have taken name is equal to one variable I have taken here, uh, Srinivas, right? If you see the type of here, if you see the type of print name along with what type of data it is here, it is of string type. So Srinivas is a value stored in name variable and it is a string type. You know already this same name can be stored with double quotes also, same name. Double quotes also, same. In Python, double quotes and single quotes are same. Okay, there is no difference. So when you exclude this again, the same result will be there. Okay. Here, to store any of these alphabetical alphabets and numeric both. We can suppose if you want to store some n is equal to within the single quotes, you can give 1 2 3 4 5 like this number. What type of data it is? String type only, because we have kept in a single quotes here, so that automatically takes this number n is a string type only. Okay. Here, suppose if you have some multiple lines of string, if you want to store, you know how to store a single value. Suppose here a single values can be stored here by using. So what is the purpose? First of all, the purpose of this one is to store string type data. Okay, to store string data or text data or alphanumeric data or numeric data also. So this is the purpose of str type of data. And string is a collection of characters, right? Or sequence of characters. We can take this as a definition is here. Can take it is a str or string is a sequence of characters or alphanumeric data or numeric data. Or any type of data that is enclosed with quotations, quotes. Okay, those str or string is a sequence of characters. See, for example, in this one, suppose here, name contains Srinivas. Now, suppose if I'm telling you one small example, this for I in name print I అన్నామనుకోండి, ఇక్కడ ఏమవుతుంది? ఇక్కడ చూడండి, ఇక్కడ ప్రింట్ అవుతుంది అన్నమాట. అంటే ఏం లేదు, ఇక్కడ మనం చిన్న ఫర్ లూప్ వాడాము. మళ్ళీ చెప్తాను నీకు ఫర్ లూప్ ఎలా వాడేది అనేది. జస్ట్ ఎందుకు చెప్తానంటే, ఇది ఒక నేమ్ అనే ఒక వేరియబుల్ లో మనకి సిరీస్ ఆఫ్ ఆర్ సీక్వెన్స్ ఆఫ్ క్యారెక్టర్స్ ఉన్నాయని చూపించడానికి ఇక్కడ చూపిస్తున్నాను మీకు. ఓకే, సో ఫర్ ఐ ఇన్ నేమ్ అంటే ఫస్ట్ టైము ఐలోకి వచ్చేసి ఎస్ వాల్యూ వస్తుంది, అది ప్రింట్ చేస్తున్నాము. సెకండ్ టైము ఆర్లోకి వెళ్తుంది, ఆర్ స్టోర్ అవుతుంది ఐలోకి, అది ప్రింట్ చేస్తున్నాం. అలా మనకి టిల్ ఎండ్ ఆఫ్ క్యారెక్టర్స్ వరకు వెళ్తుంది అన్నమాట ఈ ఫర్ లూప్. అందులోనే మనం అన్ని ఇటరేట్ చేస్తుంది, ప్రింట్ చేస్తాం అన్నమాట 1 by 1 క్యారెక్టర్. సో దిస్ ఈస్ ఇండికేటింగ్ దట్ ఏ స్ట్రింగ్ ఈజ్ ఏ sequence of characters. Suppose if you store in this one other string like this, welcome 1 2 3 like this. So if you execute it, so here like this, here WLCOME space also is indicating as a single character here. Remember this. And 1 2 3. So a string is a sequence of characters or alphabetic characters. Also you can store like this here. In this name you can store some instead of 1 2 3, or also you can also store some like this, some kind of special characters here. All those will be printed here. It may be containing any character, but it should be enclosed within a single quotes or double quotes. That is called a string data type. Okay. So in Python we can store these strings, types of strings. Here in Python we can store one is single line string data, and second one is multi-line string data. Single line is nothing but whatever we have seen like this here. For example, we have seen here this one is a single line, right? name is equal to some name. Suppose if you want to store some multi-line, suppose if we want to store here address is equal to, so at that time you can use multi-line with the help of 3 single quotes like this. For example, here Srinivas, and then so and so flat number, so and so address. I wanted to store some 101, some Park Avenue colony. And then here Hyderabad. And then here pin code is so and so 500. Like this. See here, this is containing multiple lines, right? So to store this multi-line strings, we used to have this 3 times single quotes or 3 times double quotes. Okay. So if you print this address here, that will be printed like this, print address. This is the, so to store multi-line strings here, we use 3 single quotes or 3 double quotes. This is also a string, but it is containing multiple lines. That is called multi-line data, multi-line string data. Understood this? Okay. Now coming to STR memory management. Consider, suppose for example you have a string s1 or s is equal to some welcome. So this is one string, right? So when we execute, generally when we execute this in Python, the memory will be allocated as of string type data. But here, this is like I will show you with paint. Suppose here I am taking this string here. Okay. WELCOME. Okay, this is a string. We have stored it in yes. Okay. So internally here, oh, and then here I am storing this. Here internally Python is storing this number in a indexing manner, like W is a single character, and again here E is a single character and L is a single character here, storing in a memory. And then here C is a single character and O is a single character, M is single character and E is one character here. So you can take this as here. This is stored internally in Python. Here it is treating as here forward indexing, like here it is starting from here to here. So this is called forward indexing. That is left to right. Taking this as or you can take or positive indexing. For example, here it is taking this one as this is 0, index 0, and this is 1, and this is 2, this is 3, this is 3, this is 4, this is 5, and this is 6. Okay, so this is called forward indexing. This is index of this W is 0 and index of E is 1, like that 1, 2, 3, 4, 5, 6. Totally 7 characters. Totally, how many characters here? 7 characters are stored in this S, string S. Okay, and these are internally stored each character in a separate bytes in memory. This each character is taking 1 byte of length of characters. Okay, and here when we want to access these by using indexing method, so this is taking 0, 1, 2, 3, 4, 5, 6 are the index numbers in the forward indexing, left to right. The same kind of like here the backward indexing, like here this is a backward indexing. I'm just typing here. That is right to left or a negative indexing. You can take this as negative indexing. That means here when we store these values here, if you want to access these values here internally, this is treated as this is -6 and this is -5 and this is -4 and this is -3 -2. Sorry, ఇక్కడ మిస్ అయింది. Sorry, this is -5 only. This is -5. This is -4. This is -3 and this is minus. And I'm on the 7th total characters. So
Earlier was correct. Earlier was correct.
actually -1, -2, -3, -4, -5, -7. Actually, this is not correct. This is the correct one. 6 starts with 7 and then again 5. This is 4, -4. This is -3. And this is -2 and this is -1.
So there is no 0.
No, there is no 0 in the backward.
Okay.
Only in the forward only is taking this 0. So internally the strings are stored as a sequence of characters and the indexes are starting from 0 to 6 here, 0, 1, 2, 3, 4, 5, 6, because welcome contains totally 7 characters. Okay. See, for example, the same thing here, I wanted to see the example here. For example, here S is equal to, I have stored here WELCOME. So if you want to see the first or here print of S of 0 within the square brackets, we can access it. S of 0, what is that? W. And then here if you print here 1 like that, if you print 2. See here, 0 is the index of this W, 1 is index of E. Like that we can access each character by using these indexes. Understood? Okay. So like that we can access. If I
Index
want to access
actually,
here, tell me.
can we print the index value of the value?
What is that?
I want to know what is the index of last letter E.
E.
Mm-hmm.
Yeah, we can also print it. Let me finish this one. So like this we can access each character. Suppose if I want to access here the W character first here. Suppose here print of S of -1. Tell me what is the value of -1 now? Yeah, according to this indexing, negative indexing here. Oh, I stored here. Sorry, this minus here, -2. Oh man, ఇదేంటిది? Just taking other value. Okay, no problem. You already understood this kind, right? So if you want to access this -1 only, I'll print it in a separate separate cell. Here E is a -1 index of this from the backward. If you give here -2, what is the value? Tell me. M is the character, right? So like that, suppose if you are trying to access here print of 0 1 2 3 4 5 6, right? If I want to access 0 S of 7, is it possible? Not possible. String index out of range is the error, because we have only 7 indexes of this string. S is containing welcome, that has only totally 6. That is 6 is the last index, but we don't have 7. So we'll get this error. And there is another concept called slicing concept. Suppose if we want to extract, like here the slicing concept is nothing but here the syntax of slicing is here some string data, str data, or variable of begin and end. I want to extract here, I want to extract from forward ELC. I want to extract these characters. How to extract it? Starting from 1 to how many? 3, right? So we can slice it like this. Here print of S of, what is the index of E here? 1. Beginning is 1 till 3, right? Give like this here is giving 4 means here 4 we have to give ELC 1 2 3 1 2 3 4 totally 3 characters here. So when I check here 0 1 2 3 are there, right? So 1 is belongs to this E and 2 L and 3 is C. It is excluding the last one. When you give in this Python here, when you give this 1 2 4 means it excludes last characters. 1, 2, 3, only 3. Suppose tell me now, I wanted to extract only WEL. Now tell me, print S of 0
0,
to
2.
3 characters I wanted to print.
0, 1, 2,
3.
2.
No, it excluding, it won't print the last index. It excludes that one. It omits that one. So we have to take here 0 to 3. So this is called slicing. Extracting some of the characters from the given string is called slicing, or obtaining some range of characters from the given string. Okay. So these are the different ways to extract. That is here. First one is this one. And second one is we can take this some str data of only we can extract from giving begin only. You can keep it as empty, the second one. And third one is here str data of begin, or you can take colon end. And fourth type is here str data of only colon. It takes entire characters. Here begin, end, and step. So these are the 5 rules of declaring this extraction of strings here. See, begin. Suppose if I give here, if I give print of s of, if I give from second to end, only I have given begin, not given the end. End is empty. That means till end of the characters, till end of the string here. So here 2 means what is the 2 index here? 0, 1 to L. From L to till end. This will be printed here. See here. LCOME. Right? Like that, print of, what is the next syntax here? End, if I give here 5 here or 6 here, what will print now? We did not give any beginning character. It starts from 0 till 6th. That means excludes 6th. 5th character is, what will print now? In welcome, 0, 1, 2, 3, 4, 5, 6. That means till end here. It prints total. Excludes the last character, 6th character, that is WELCOM. If you want to print entire string, like here S of, you can give just only from beginning to end. Okay. Suppose if I want to print like here, starting is 0, print the till the 7th character, total 7 are there. Step 2, S of, this is what I wanted to extract. Step 2 means here it skips each character, one character. Now see, WL, basically what is that here? W is skipping this one. L will printed. This is skipping this one. Step, we are giving step 2. So it skips 2 characters. That means here one after one. So WLOE will be printed. WLOE. So these are the different methods to extract the characters from the strings using slicing method. So